This is a flipped lecture for 5.1, Introducing Forces. This is a mighty short section in Knight, just 2 pages. And he's just introducing something. He doesn't really go into it that much. But still, there's really important stuff here, so I'm not going to skip over it. Let's look at what Knight says. He says a force is a push or a pull. He says a force acts on an object. He says a force requires an agent. He says a force is a vector. He says a force can be a contact force, or it can be a long-range force. Let me unpack a few of these things. First of all, a force can be a push or a pull. Okay, here I am. I'm actually pushing on this eraser right now, but now I'm going to push on it extra. I pushed on the back side of the eraser. Something happened. We're not going to worry about that quite yet. The important thing here is there was this idea that I pushed on the back side of the eraser. Now, a force can be a pull, either if you are able to grip something or maybe your hand's sticky. If your hand's sticky, then you can pull the thing towards you. So a force can be a push or a pull. In truth, a force can actually also kind of go sideways. So it doesn't actually have to be directly opposed or directly towards. You can transmit force sort of sideways as well. There's 2 things here that is really important. I pushed on the eraser when I did this. I pushed on it. The way Knight says that is a force acts on an object. In this case, the force is acting on the eraser. And a force has an agent. The agent is, in this case, my hand that's pushing on the eraser, or you might say me that's pushing on the eraser. So there's sort of 2 parties involved here, and you have to be extremely clear when you're talking about a force. Are you talking about me pushing on the eraser, or perhaps you may notice when you do this that you actually feel the push of the eraser back on your hand. You sense that. Those are actually 2 conceptually separate things. The force of you on the eraser, the force of the eraser back on you. So let's draw this little eraser here. Here's my eraser. Here's me pushing on the back side of the eraser. And the way we draw a force is, if we're talking about the force of my hand pushing the eraser, well, it has an amount and it has a direction. And in this case, I was pushing that way. And what we do is we attach the tail of the force to the thing that it is acting on. We don't attach the force to the thing that is doing the pushing. So that would not be correct. This is just a convention. As you know from past chapters, a vector is a vector is a vector no matter where I put it on the board. So if I wanted to take this vector and put it here, I am welcome to. And it's still, if it's got the same size and direction, it's still the same vector. But by convention, we put the tails of a vector on the object that it is acting on. Another major concept about forces is addition of forces. So as an example of a long-range force, the one that you know about the most or experience the most is gravity. Here's my eraser again, and what I've shown here is the force, which I've now called F1, which is the force of my hand on the eraser, and another force that I've called F2, which is the force of gravity, which we're going to learn is yanking downward on the eraser. Okay, and that's happening even though the Earth isn't in direct contact with the eraser, so this is called a long-range force. So we have my hand acting on the eraser, represented by that vector, and gravity acting on the eraser, represented by that vector. And when we want to talk about the total force on the eraser, we just add them up. So we can say F net or F total, so pretty much synonyms, is equal to F1 plus F2. By the way, if there were n forces, not just 2, if there were n forces, I could say this is sum I equals 1 to n of F sub I. So in the case that n equals 2, this sum represents a sum from I equals 1 to 2 of F sub I. That would be F1 plus F2. But in general, we can have a lot of forces that are simultaneously acting on an object. That's pretty much all of 5.1. I'd encourage you, as always, to look closely at Knight. Make sure you understand his notation and the additional care that he's taken to lay these things out very precisely. And then we'll go on to 5.2.